Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. So you've seen sine, cosine, and tangent before, but have you ever wondered how they're all connected? In this video, we're going to explore quotient identities, which are special relationships that come directly from the definitions of the trig functions. By the end of this video, you'll be able to explain where the quotient identities come from and use them to rewrite trig expressions. The two quotient identities we have are tan theta is equal to sine theta over cos theta. And the other one is cotangent theta, which is what this COT stands for, is equal to cos theta over sine theta. So we haven't exactly talked about cotangent before, which we will go in depth in the next video. But for now, just know that cotangent theta is equal to 1 over tangent theta. So it's basically the reciprocal function of tangent theta. And now for the proofs. So from our previous trig knowledge, we know that these trig ratios can be obtained from the sides of a right angle triangle. So if we have a right angle triangle, and we're going to label our angle theta here. So let's say this angle here is our theta, and this here is our right angle. Then we know the side across from the right angle is always the hypotenuse. And the side that is across from our angle theta is our opposite side. And then the side that is touching our angle theta is going to be the adjacent side. Now, SOHCAHTOA tells us that sine of theta is going to be opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. So then what happens if we take our sine theta and we divide it by our cosine theta? Well, then we're going to get our top is opposite over hypotenuse, and then our bottom is going to be adjacent over hypotenuse. And since we have a fraction divided by a fraction, we can go ahead and change this to multiply and flip our bottom fraction. Now we can see that the hypotenuse is going to cancel out, and we're left with opposite over adjacent. And this is exactly tangent of theta. And now quickly for cotangent theta, since that is 1 over tangent theta, this is going to be equal to 1 over sine theta over cos theta. So now we just go ahead and flip our bottom fraction, and this becomes cosine theta over sine theta. These quotient identities allow us to see how tangent and cotangent can be written in terms of sine and cosine, because those two are the ones that we're more familiar and comfortable with. Now let's go ahead and put what we learned into practice. We want to simplify this expression here into one fraction. So we start with sine theta over cosine theta plus cosine theta times tangent theta. And the first thing we're going to do is we're going to use our quotient identity and change our tangent theta into sine over cosine. So that means we're going to get sine theta over cos theta. So that's the first term. We're not doing anything with that. And then we have our cos theta multiplied by sine theta over cos theta. And now we can see we have a cos theta on top and a cos theta on the bottom, which will cancel out. So that means we're left with sine theta over cos theta plus sine theta. And since our goal is to turn this into one fraction, we're going to put them over common denominator, which means we're going to multiply our second term by cos theta over cos theta. So this is going to be sine theta over cos theta plus sine theta times cos theta over cos theta. And now, since we have a common denominator, we can combine our two fractions. So this becomes sine theta plus sine theta cos theta on top. And this is all over our denominator, which is cos theta. And now one additional step is that we can factor out the sine theta from the top. So we get sine theta times 1 plus cos theta over cos theta. For our last example, we're going to solve this trig equation here. We want to find where sine x is equal to cos x for x in between 0 and 2 pi. So using what we learned, we can go ahead and divide both sides of this equation by cos x. And that's going to give us sine x over cos x is equal to 1. But since we know that sine x over cos x is just tangent x, this is now just tan x is equal to 1. And we know that this is just a special angle. So this one is going to give us a reference angle, which we will call x sub r, and that is equal to pi over 4. So now that we have the reference angle, we're going to go ahead and draw our 4 quadrants. We're going to label them with our A, S, T, and C. Since tangent here is equal to positive 1, that means our solutions are going to be in quadrant 1 and quadrant 3. And for each of those, we're going to have a reference angle of pi over 4. So it'll be over there and down here. So within our domain of 1 full rotation, we have 2 answers. The first one is we have x is equal to pi over 4, or we have x is equal to 5 pi over 4. And now let's go ahead and do a quick recap of everything that we covered in this video. We learned how tangent and cotangent are directly related to sine and cosine by the quotient identities. And since they're a quotient, they are going to be undefined when the denominators are equal to 0. And the purpose of these quotient identities is that we can use them to rewrite everything in terms of just sine and cosine so that we can simplify our trig expressions. And now it is your turn to give this a try. Can you simplify this trig expression on the screen here into one term? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on trig identities in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.